We can start.
Okay, hello everyone. My name is Valentina. Thanks all for joining in. Today's topic would be smart Capex planning. So how we did it at ThinkSolver for a telco use case. Basically, as a short introduction, I will going to talk about the company that I work for, which is called ThinkSolver. Basically, the company is founded in 2015. Currently, there are 21 of us, data scientists, data engineers, developers, DevOps engineers, etc., etc. And we are specialized for building data products. So basically, everything that has something to do with the data, from integration, streaming, maintenance, through the advanced analytics, machine learning, AI, and interactive dashboards. So basically, we have projects and clients coming from different industries like telecommunications, banking, insurance, retail, real estate, aviation industry, etc. And here you may see some of our biggest clients: A1, Telecom Austria Group, Bank Intesa, Planet Sport, Gomex, DIS, OTP, etc. So basically, what we are going to talk about today is smart Capex planning. So capital expenditures, and the use case is a specific implementation in telecommunications industry. So I will give a brief introduction into telecommunication network. I'm not a telco expert, so it will be really brief and short. So basically here you may see one simplified representation of a telecommunication network. So hopefully you can see what I'm pointing at. So these are the main parts of a telecommunication network. So you have base stations. The users are connecting through the base stations by which they get some service, get a call to another user, etc., etc. Base stations are mutually connected through some links, microwave links, with another base stations or with hubs, which are like the main base stations holding some part of the network. And hubs are, in most cases, connected to the network core through optical links for reliability reasons. So basically, every request that you have goes through the network core, because this is the brain of the network, and here all the requests are being handled. So basically, if you are this user here, you want to make a call, for example, you get connected to this base station and your request goes to the network core, where it should be handled like, do you have enough money? Is this call roaming or not? Which service do you want to access? Is it message or voice? And then it gets transmitted to the other end user that you want to call, or to the service that you want to get. What is our use case here? Well, basically, you have like this number of users here connecting to this base station. And if this number of users is getting higher and higher, so it is increasing, in one point of time, this base station will get congested, because it won't be able to handle all these users, because the capacity is really limited. And the main task here is to determine where and what is the right time to expand the network with some new component, whether be it new base station or new cell or some carrier aggregation. So some, domain specific terms here, but basically where to invest in which part of the network, when, and how much is it going to cost, in order to prevent these users to be degraded and to feel the congestion and the load. So basically, we are coming to the problem definition, which was here, Capex planning resulting in too much money spent, low performances, degraded user experience. So the main idea was to optimize this whole process. So let us recall again, what is smart capital expenditures planning? Well, it's about automating and improving current processes of making strategic decisions, such as frequency band acquisition, integration of new sites, upgrading to new carriers, introducing new technologies, etc., etc. Here specifically, I will talk about the machine learning implementation. So basically, we try to embed machine learning to create some projections, so predictions of future behavior in order to define and to help the decision-making process, to define action and help decision-making process. And basically, this module that we have developed is dedicated to finding the answers to some main questions like when, where, what to invest in, how much this will cost, and what is the expected ROI, because those are the essential key points that are used in strategic decision making. So if we come to the project requirements, as I already mentioned, there were a couple of questions that we needed to provide the answers to. So the first question was answering when. So when is the right timing? So when is the right time to perform some expansion in order to prevent the congestion? So you don't want to expand the network too early, but you don't want also to expand it when it's late. So basically, the first question that needs answer is when to expand the network. Another question was where to invest. So not all parts of the network, because network is like huge. You have lots of entities here, several thousands of cells and the sites as well. So you need to know where exactly you should perform some expansion. So not all parts of the network behave the same way, and only some parts need expansion at some point of time. Another question that you need to answer to is what. So what is the best expansion? So what is the optimal expansion that should be introduced in order to optimize this trade-off between the money that you invest and the return of investment? Fourth question was about investments. So basically, how much is that expansion going to cost? Because whenever you invest in something, you expect some money to be returned. So the final question was to answer the question, what is the expected ROI? So what is the expected return of investment? Because this is something that is really important to answer in this decision-making process that has to be applied within Capex planning. So basically, those were our project requirements. And here you may see the graphical representation of our solution. So I tried to make it as simple as possible. So basically, this here in the middle is our solution, and our solution takes some inputs and provides some output, right? So what are the main inputs that we have used in our solution? So the first one is state. The state component represents the state of the network. So we focused on this radio access network part of a telecommunication network, and we analyzed the radio KPIs that are coming from base stations, describing the cells within base stations and base stations themselves. So the state, for example, is what is the traffic, number of users, spectrum efficiency, utilization, etc., etc. So lots of KPIs that are describing the behavior of each component within a network. And based on that state, we generated context. So I will talk more closely about the context itself, but basically this is the main part of the module, because not all parts within the network are the same. So you should provide some context by which you analyze each base station. The next thing are projections. So here is the core of our machine learning application. So basically we perform some predictive analysis on forecasts in order to get projections of future network behavior, and then to enter that into our module as well. Besides these three, we created also what-if model, so to say. So the what-if model had the main task of generating the answer of what happens if we change some parts of the network, some KPIs, what happens with the rest of the KPIs. Beside this, we also had a predefined set of actions. So those are the possible expansions that you can perform within the network. And the idea was to combine all these inputs, so state, context, projection, what-if model, and actions, in order to provide the answer to what is the optimal expansion for each part of the network in terms of what are the costs, what is the expected capacity gain, and what is the expected ROI. Because these three outputs were used by our domain expert in creating final decision of what and where to invest in. So this is a simplified representation of our module. Before going into the details, I would like to point out this here. This is a picture that I took from a scientific paper written by people of Google, which is called, if you want to Google it right now, it is called the hidden technical depth in machine learning systems, which says that basically, if you're dealing with some real world machine learning problem, only a small fraction of the code here, represented in this pink color, only a small fraction is composed of machine learning code. The rest is something that has to do with infrastructure, configuration, streaming, data preparation, monitoring, visualization, interactive dashboards. So basically a lot of other components that are way too bigger than the machine learning codes that you really have and develop when you're dealing with some real world machine learning problem. So if you are dealing with some real world machine learning problem, I would really recommend you to read this paper because it is really important and helpful. It talks about all these technical depths in terms of entanglement, glue code, legacy features, undeclared consumers, etc., etc. Lots of problems that may occur when you're dealing with some real-world machine learning problem. And it also gives some recommendation on how to do it the right way. For example, code refactoring, unit tests, writing documentation, deleting that code, and it is really helpful, so nice and warm recommendation for you to revisit this paper and think about it more. So basically, if we are talking about our use case, here you may see the ML, so the machine learning code of our solution. So there are lots of other challenges and components that we have developed from the data engineering perspective, from the development perspective, but here we are talking only about the machine learning. And here you may see the main building parts of our solution. So we have used segmentation, forecast, regression, combined that into some expert system, and then generated some outputs that were used by our clients. So basically, the first step was to create the context, as I already mentioned, and that is why we have used segmentation. So since we have like several thousands of entities, they have their own behavior, their own KPIs. So we needed to create some context to identify different types of cells, like high performance, low performance. Those are urban cells, those are rural cells, those are cells in the urban area that behave as rural cells. So basically to extract different clusters of cells based on their KPIs in order to prioritize them. So all the analysis that we have performed has been performed on different clusters of cells, because not all clusters have will have the same, let's say, actions that will be defined and the same priority that will be defined, because you have to prioritize some cells based on their congestion score, based on the number of users, based on the return of investment that they have, etc., etc. So the main challenge here was to identify those different clusters within the network. For the segmentation purposes, we have used different clustering algorithms, finally come up with the simplest one like k-means, but we have also tried, for example, DB-scan, but got the best results with k-means, so we stick to the k-means clustering algorithm, which really provided nice results. After we have created the context and identified different clusters of cells behavior, the next step was to create some projections. So the projection should tell us, so give us the answer to the question, what is the expected behavior of this part of the network, of this cluster of cells in some future period of time. So for example, here the main task was to forecast traffic growth and the number of users growth. So basically, we needed to give the answers to what is the expected number of users, what is the expected traffic growth, because the traffic growth and the number of users, they directly influence the load, so the congestion that we will have, because if the capacity is static and we have like increasing number of users and increasing amount of traffic, we will finally get into congested state. So here, for the purpose of creating projections, we have tried lots of different algorithms and approaches. So we have tried from univariate analysis, so forecasting only traffic, to multivariate analysis, forecasting traffic and number of users based on some other features like utilization, efficiency, etc., throughput, etc., etc. And the main idea here was to come up with the answer what will happen in the future, because this is directly connected to the action or the decision that we need to make and to create. We have, well, since this is done like several months or even years, it has really had lots of challenges. We have played with different sets of algorithms. So we tried with ARIMA, vectorized ARIMA, LSTM, so univariate, multivariate, and finally we have come up with the Facebook profit algorithm, which really gave good results for us, because it is able to deal with seasonal data, with data having a trend, with problems like holidays, trend change points. So it has really a nice set of features and parameters that you can set up, and it really answered our needs. So because in telecommunication network, you really have these seasonal effects, trend effects, holiday effects. So basically, Facebook Profit gave the best results for us. So we finally developed a Facebook Profit algorithm for this task. After we got projections, the third step was to develop a what-if model. So for the purposes of what-if model, we have developed a regression model. So basically, the main idea here was to give the answer to what will happen with some set of KPIs if some other set of KPIs changes, or basically it's a simple regression problem where you have some inputs and you should return some output. So in our case, that was what will happen with the throughput if we change number of users, traffic, utilization, etc., because we got that from the forecasting algorithm and from the projections. So the idea is to provide the estimation, to define some critical KPIs that will be analyzed. And for the purposes of this regression problem, we have also tried lots of regression algorithms, different regression algorithms. And finally, we have come up with the ensemble algorithm, which was really problematic in the production because we have used some scikit-learn implementation, which is not so good if you're using it into production. It has some performance issues, not to bother you with that, but finally it had the best results, the really high accuracy. Average accuracy was 85%, so for us it was more than enough. So basically, after we have developed this what-if model, so what will happen with some main KPIs that should be observed if some other KPIs are projected to behave in some specific way. This was the output that is finally used in decision-making process. So the main idea was to generate some decision. And this fourth step was to create some expert systems. So no big deal. We had some knowledge base. So basically the knowledge that we obtained from our domain experts. We had some facts that are generated from the segmentation, from forecast and from regression models. So those were some main inputs that we entered this expert system. We had some predefined set of actions, and based on our knowledge base and the inputs that we got from our domain experts, we have defined some rules. So what to do if you have some facts and you have some possible set of actions. Based on the previous experience, we have defined some set of rules of generating the best expansion proposal, so to say, and to provide that to the end user in order to act, so to create final action. So in the expert system, we just put it all together, no big deal. And basically here you may see some short wrap up of the whole use case. So practically the main task was to, based on the experience, to generate some facts, to identify bottlenecks and most fragile parts of the network. The next step was to develop some machine learning algorithms that will provide insights, provide projections of future behavior and estimation of growth and congestion. After that, we have put it all together in expert system to generate a decision of where to invest, which investment is optimal, and what are the costs and expected return of investment. And as the final step, since it's a business issue, we have the users to create final action, because lots of money plays a role here, so we could not automate it completely. But we have the final users, or the clients, that are using insights obtained from this module in order to take actions based on the recommendation that we have provided, and to monitor the future state of those actions. If we're talking about the project benefits, besides data-driven decision-making, right timing, better investment planning, I would like to point out two main benefits that we have identified. One is the benefit in terms of time needed for generating the action. So basically, in consultation or in provided feedbacks from our client, we got the answer that the whole amount of time that was needed previously to get to the final action that should be obtained, we managed to reduce that time from 30 man-days to only a couple of hours. So basically, that is something that is the most important thing beside the money. And in terms of money, unfortunately, I cannot say the right amount. I can only say that it is numbered in 6 zeros. So the money that is saved is pretty high. And those two are some of the main benefits that we have identified of providing this solution to the client. And I would only like to wrap up with challenges. So I only had 20 minutes to talk about this, but hopefully we will have Q&A session where I can answer some of your questions. Well, this solution that we have provided is still ongoing. It has lots of other challenges, future improvements that need to be introduced. Like we'll have some completely new technology that should be implemented. So we need to figure out how to analyze and how to provide the answers of where to invest in new technology, how much this will cost, and what will be the expected network behavior if we expand the network with completely new technology and components of new technology. So that is one challenge. Another challenge will be also to try to create some simulator where the client can enter some, dynamic inputs for configuration, like dynamic prices for actions, dynamic actions. Now we have only fixed amount of actions in our configuration file, but the next step will be to generate this simulator where the client can enter some configuration parameters, and we should provide the answers based on the configuration setup. So those are some of the future challenges that we are going to face, and hopefully I will also be talking about them in the future as well. But practically, I would wrap up my presentation with this. slide. And now we can go to the Q&A session if that is okay with you, because I think that I'm really tight on here schedule for the presentation time. So Mario, I will give you the word now. Hopefully there are some questions from our audience.
Yeah, so first of all, thank you, Valentina, for joining and for giving us this great presentation. So I'm no expert in the telco industry, but now I think I got a bit more understanding what's going on there. So we're really tight on schedule, as you said, but still I would like to ask you 3 questions, partly also from the audience. So the one is regarding the projections you're doing. So one thing is, are you doing the projections only based on past data, or are you also using data which, you know, will influence the network usage further? And have you also tried other engines like Facebook Profit? And how do you think those kinds of different data or engines could further improve your projections?
Yes, so basically we are creating our projections based on the past behavior, and by entering some inputs, we are using Facebook Profit. So we enter some inputs regarding the growth, whether it is linear or logistic. We enter some information about the trend change points, because you have the opportunity to set that in Facebook Profit. So basically we are only using the past behavior, and that is something that will be like a huge challenge for us with introducing new technology, because for the new technology we don't have past behavior. So we will have to figure out how to create those projections for the new technology for which we don't have past behavior. But basically, we are modeling only on the past behavior and some additional parameters regarding the growth. So the logistic or linear growth, trend change points, holidays, etc., etc.
Okay. And speaking of holidays, how much do special events and also contribute to your projections? So are you all, I mean, during the Corona times, maybe there are not so many concerts going on maybe, but how does this also affect your model?
Yes. So basically, a very nice question. I forgot to mention that we have this solution like implemented in different countries. So it's like a totally different behavior of the network for each of these countries. So we have huge seasonal effect, these periodical events. We have, for example, in Serbia, the characteristic that each Tuesday we have like a peak in traffic, because you had this Champions League streaming on Tuesday, so everybody used the internet for streaming the Champions League on their, I don't know, phones or laptops. So basically, Facebook Profit is good for that. So for catching seasonalities, for dealing with outliers, for everything. That is why we have used Facebook Profit, because it is really simple and it can model all these characteristics and special events or peaks in time series that you have. On the other side, when we tried with ARIMA and other models, they really like stationary data. So it was pretty challengeable to create stationary data. That is why
we Profit worked best for you.
Yes.
And one last question maybe, because unfortunately we were really short on time. If you have any more questions, please send Valentina directly an email or via LinkedIn, I guess. So regarding capacity planning, that's just from my understanding, because I'm not an expert there. Are you actually just planning for the peaks? So do you have to provide the capacity only for the peaks, or why did you also have to forecast then the seasonality behavior or something like that?
Yes. Okay. So for the capacity, no, we have used the data for example, busiest hour in the day, and we have modeled the behavior on a week level. So practically you don't model the capacity. You have the capacity, which is like static. You know how much capacity you have within your network.
But it should be enough to also handle the peaks, right? Or
yes, that's right. But you have like increasing number of users and increasing amount of traffic. And if you're increasing the traffic and the number of users and the capacity is like static, you will at some point of time get into the congestion, high load, because load is like calculated like traffic divided by capacity. So practically that.
Okay, so the peaks should be handled maybe also for months and years ahead. I don't know.
Yes, that's right. That's right. Now we are dealing on a yearly level, but the idea is also to like provide a more higher, how to say, a longer period of time. So like several years, because that is something that really is more useful for decision-making process.
Okay, cool. So again, thanks Valentina for giving this great presentation. And also for the rest of our attendees, there's the next session going on now with the Fireside Chat on enterprise data strategy with Mario Huber, also from A1, and looking forward to it, and see you in a minute.